Kangaroo Island, a major South Australian tourist destination. An island of remarkable contrasts. Stunning scenery and abundant wildlife, attracting 100,000 tourists annually. A population of 4,000 scattered in small towns and on farming properties. But all dependent on the one necessity of modern life, electricity. And up until now, relying on an aging, decaying submarine cable. And in the event of failure, these less than adequate diesel generators. This umbilical cord from the mainland was rapidly degenerating towards a major failure. With severely corroded armour wires, the cable was vulnerable to irreparable internal damage. The original cable was laid in the mid-60s as part of the Electricity Trust of South Australia's commitment to bring a reliable supply to the entire island. A supply by now in jeopardy and needing further commitment for a replacement cable. One of integrity to fulfil the island's needs well into the 21st century.
With the strength of over 50 years of cable manufacturing in Australia, Cables was strategically placed to fill the requirements of the new Kangaroo Island cable for ETSA. Cables is the largest cable maker in the Australasian trading region, with the capacity to produce cross-linked polyethylene cables up to 66 kV. Cables is accredited by Standards Australia as a quality endorsed company to the highest national and international standards. The cable's three cores consist of compacted copper conductors insulated with cross-linked polyethylene, or XLPE. The XLPE is applied as a triple extrusion of semiconductive conductor screen, insulation and semiconductive insulation screen. A lead sheath encloses each core to provide a metallic moisture barrier, followed by a PVC protective layer. After laying up the core assembly, a PVC sheath is applied as bedding for 2 layers of brass tapes, protection against teredo seaworms. As protection for the cable, 2 layers of heavily galvanized steel armour wire are added. A layer of bitumen-impregnated polypropylene rovings completes the process. A solid, uncompromising cable measuring 112 millimetres in diameter and weighing in at 26 kilos per metre. More than capable of withstanding the rigours of life on the ocean bed. A 14.6 kilometre lifeline running up to 60 metres below the turbulent waters of Backstairs Passage. The first stage of manufacture took place at Cable's Fairfield factory. In fact, this is the setting for the majority of the cable's creation. A single strand of copper wire becomes the central point around which other strands of copper are twisted. Over and over, crisscrossing each other until the conductor is built to the required size of 50 square millimetres. Eventually, 3 conductors will form the cable's core assembly. But before that comes the next step in the process. From Fairfield to Cable's Liverpool for the triple extrusion. This is critical to the functional integrity of the cable. 3 layers of XLPE, a black conductor screen, clear insulation, and a 3rd tier of black insulation screen. The semiconductive conductor screen is first extruded onto the copper conductor. Then follows a dual layer of insulation and semiconductive insulation screen. Curing of the triple extrusion takes place in this long tube before the cable core is checked for correct thickness. Testing is also carried out at Liverpool to ensure each layer of the triple extrusion meets specification. Just one of many quality control checks which follow the cable's construction. Back at Fairfield, the cable receives its first layer of protection, a lead sheath to provide a moisture barrier.
The sheath is applied by running the cable into an extruder where lead is applied as a continuous uniform tube. An ultrasonic gauge measures the thickness of the sheath. An extrusion of PVC follows to protect the lead from corrosion. To cool the hot PVC jacket and keep its shape uniform, the cable is run through a long trough of water. Now, drums of cable are loaded onto the laying up machine, a sort of giant loom which will bring the threads together to form the central cable assembly. 3 cores are laid together with polypropylene fillers and bound securely with holding tape. Next, the whole core assembly is covered in PVC in a process similar to that applied to the lead sheath. The PVC acts as a bedding for the 2 layers of brass tape, another protective coating for the cable. The brass is an essential barrier to the teredo sea worm, a creature which can destroy a submarine cable. A layer of Hessian tape is next applied to the cable as bedding for the final stage of the manufacturing process. This is the heavy-duty stage. Heavily galvanized steel wires, 3.15 millimeters in diameter, form the backbone of the cable. Armouring is essential for protecting the cable against rocks, tides, and the odd boat anchor. The old Kangaroo Island cable was only given 1 thickness of armouring. This time, ETSA and cables will make doubly sure. The first stage of armouring consists of 78 wires. As they're wound on, bitumen compound floods the gaps for corrosion protection, and then a layer of Hessian tape becomes the bedding for a second stage of armouring. The whitewash simply ensures the cable does not stick to itself on the drum. The second layer consists of 91 wires. It's absolutely vital that these are laid in the same direction as the first pass to make coiling easier. Again, the gaps are flooded with bitumen, followed by a final outer layer of polypropylene rovings for further protection against the elements. A last bitumen bath and a coat of whitewash, and the finished section of cable is rolled onto a drum, ready for jointing. ETSA specifications required a series of rigorous tests prior to the start of manufacture and on each drum of finished cable. Initially, type testing was carried out at the laboratories of Testing and Certification Australia, a division of Sydney Electricity. Then during assembly and prior to dispatch, routine partial discharge and high voltage tests were performed. As each drum of cable is completed and tested, it is transported from Fairfield to the docks at Darling Harbour for jointing and loading aboard the cable vessel Derwent Enterprise. In all, 20 drums were brought to this empty warehouse for the most skilled operation of the whole process. Australian company Kilpatrick Green were chosen for this role. Their experience in installation of submarine cables made them a natural choice for the critical link in the Kangaroo Island project. Jointing is an exacting art requiring concentration tempered with an abundant patience. Firstly, the cable ends are prepared by cleaning and cutting the armour wires and removing the various layers beneath: brass tape, PVC sheath and polypropylene fillers. The core assembly is now exposed, and once the lead sheath has been cut away, the most delicate part of the operation begins. It is critical that the clear insulation is not damaged in any way, so the semiconductive screen must be taken off gently. After polishing the insulation to remove any possible blemishes, a piece of string is used to cut off the end and expose the conductor. Next, a penciling tool to taper the ends, ready for jointing. Then a thorough inspection for blemishes. Now the conductors are crimped and taped with semi-conductive conductor screen. Then follows the reinstatement of the various layers. Insulation, semi-conductive insulation screen, the application of tinned copper braid, utilising materials supplied by the Electrical Products Division of 3M Australia. The lead sheets are reinstated with sleeves of identical material to the original sheet. The final part of the core reassembly is the addition of a heat-shrink polyolefin sheath, which links those on the jointed cables. The jointing process takes about 2 days to complete. Once the 3 cores have been bound together, the joint casing is fitted and filled with bitumen compound to seal it solid. This outer casing, supplied by Cables Busway, is designed to protect the inner electrical assembly from the marine environment and also to transfer the tension from armour to armour during laying. There are 19 joints in total, a time-consuming but most important operation. Section by jointed section, the cable snakes its way aboard the Derwent Enterprise. The vessel has been specially chartered and fitted out for the lay by Kilpatrick Green. The cable is pulled through a caterpillar up an inclined ramp and gently coiled in the hold. Each layer separated and supported by timber planking. Once loaded, the 400-ton coil stands around 3.5 metres. Just 7 months after the order was placed by ETSA, the Derwent Enterprise steams out of Sydney Harbour for Cape Jervis, south of Adelaide. Five days later, on a mid-January dawn, the Derwent Enterprise moves onto station, an air of tense excitement aboard as the crew prepares for the moment. A second team is waiting ashore at Fishery Creek to receive the mainland end of the cable. It's a delicate operation, to say the least, with precision timing and positioning of the Enterprise vital to getting the first few hundred metres of cable ashore. With bow thrusters working overtime and a little help from a support boat, there's a battle between tide and man. As the cable is brought ashore, it is winched through the cable trench to the terminal hut, and the all clear is given for the lay to begin. Using computer-aided navigation equipment, the Derwent Enterprise steers a predetermined course towards Cuttlefish Bay on Kangaroo Island. Today, perfect weather for the lay, with just a gentle swell running and next to no wind. Two and a half hours later, with 13 kilometres of cable lying on the bottom of Backstairs Passage, the Derwent Enterprise is positioned to float the remaining cable ashore at Cuttlefish Bay. The rugged terrain at Cuttlefish Bay is not conducive to vehicular traffic, so all excavation equipment has been taken in by boat. There's definitely no access down these steep gullies, except by foot. Once the cable is secured, a team of divers is dispatched into the depths. This operation is hazardous and can only be carried out during a dodge tide when the current flow is at a minimum. Inspection at several locations along its length reveals no cable defects. This is another specialist operation. Once again, the Kilpatrick Green jointing team have been brought in to terminate the cable. Although not as complicated as the jointing process, the work must be exact, as the cable cores are exposed and terminated one by one. Once the cable is fitted to the 66 kV rated porcelains, a special filling compound is used to seal the system. With the terminations complete, the cable now lies like a dormant sea serpent, awaiting the gift of life, or in this case, a giant charge of electricity. Before that, the cable is put through a solid testing regime by the Electricity Trust of South Australia. This part of the operation was overseen by a representative from ETSA's Technical Services Department, as in fact was most of the manufacturing, testing, jointing and installation. Energising and loading the cable with 33 kV is a mere formality, almost an anti-climax to the months of exacting processes which have preceded. For Kangaroo Islanders, there's now the comfort and security of knowing they have a cable of dependability, bringing electricity to power their lives. Insurance for the future, thanks to ETSA and MM Cables. The energy behind cables in Australia.